Hey everybody, it's Mike for Faraday Research. It is Tuesday morning and I decided to do this little video. I haven't done a video in a while because I've been busy doing the podcast on Friday nights, and also my situation at home is getting a little tight for money because I've been out of work again. I'm on temporary layoff and my employment insurance is taking longer than I thought to actually get. So pretty much on life support right now financially. So like I've been going through a lot of anxiety and stuff like that. So mentally it's been kind of hard on me lately. So I've been kind of down in the dumps. So my wife told me, you know what, just work on your projects. There's stuff you just can't control, so don't let it eat you alive. So just kind of stay focused on your projects and get videos going and start working on stuff, and you'll be happier, and my state of mind will be better than it has been in the last couple of days. It's been rough mentally because I've been out of work, and when anybody who works on a regular basis like I do, to go from constant work to nothing, it's pretty much a shock to your system, and mentally it's not very healthy for me. So I've been in the pretty much the dumps, pretty depressed, and a lot of anxiety in the last week. So, and anyways, I want to get away from that. I got my Patreon, I got my PayPal donate. If you guys got an extra buck or two to chuck at me to help me make ends meet and keep me afloat, that'd be greatly appreciated. All the links are below in the description for my PayPal and my Patreon. I'm going to cover a few topics today in this video, so it might be a little bit long. So bear with me. I'm going to go on with Rant, what I see going on out there right now. And it's to be kind of like more or less constructive criticism more than just criticism with no backing. So we'll start with that. And the last thing I want to talk about too is how to build a core for these motors, because I've had a couple people ask me in the last week or so on how I do my cores. So I do believe I do have videos further down in my video selection there on the Faraday Research YouTube channel, and you can check those out. I have done a video on cores before, but I'll get into it again in this video here, so people will have an idea of what I'm doing as far as core design. So we'll start with that. I'll start with the Rant. Basically, I watch everything that's out on YouTube right now, especially in the last little while, seeing what other people are doing with their projects and stuff. Now, don't get me wrong here. This is constructive criticism. I don't want to come off as an asshole when I'm saying this, but this is what I see. Some guys out there are making some really, really nice motors. Excellent design, 3D printed, aesthetically, pleasing, simple circuit design, yada yada. But I don't know if they have a blind eye, or they're just not watching me, or they don't even know me, or what the case is. But nobody has caught on to what I've been doing for the last 2 years with this motor. Nobody's using piezo transducers in the circuit. You get a 30 to 50% gain in power by putting two of these in parallel with the coil. In my Patreon, I have the full schematic of how this motor is wired up, and it is ridiculously easy to do and hook up. It is not a difficult wiring schematic for this motor. It's extremely simple, and that's part of the reason why the way I built this motor. You can go to your local hardware store and pick up the materials, or go on Amazon and order some of the components and put this thing together extremely easy. I tried to make this, miniature Renegade, not like the big one in the corner over there, but this one to be as easy as possible to construct. Now, that being said, now the whole physics of my motor nobody is caught on to, and I've said time and time again, it is a current-free potential device. I got confirmation of my results by another electrical engineer. I listened to a podcast, and she was actually talking about this scenario, and it's exactly what's going on in my motor. It's called a current-free potential, and nobody has caught on to this. Nobody is doing it. The way that I've configured this motor, the way I've designed this circuit, allows the current-free potential to be possible. Nobody is caught on to it, or maybe people just don't understand what a current-free potential is. I'll explain right now exactly what a current-free potential. You got two plates that are lined up. There's plates inside the battery, okay? And you got battery acid, it's a lead acid battery, so you got your electrolyte, you got your plate, and you got your electrolyte in between that surrounds the whole battery. What a current-free potential device is, it allows the motor to pull a voltage potential off the battery and utilize it to make it work. So let's forget about that now. We want to understand what's going on inside the battery. Okay? So inside the battery, you got the ions and the radiation, or whatever you want to call the electrical flow of current. Current is what kills a battery. Okay? So if you start pulling current off a battery, eventually the battery is going to die off. Okay? So a current-free potential is exactly what it is. There's a potential there with no current involved. So the way I'm switching the motor using the spark gap switch allows me to steal the voltage off the battery without pulling a current. So by the time I pulled the electrical power or the voltage off the battery, I cut it off right away. So therefore, what happens is the ions cannot travel from plate to plate and exit the battery. So therefore, the current in the battery is not being released. It's staying in the battery. I'm just stealing the voltage from the battery. And that's what a current-free potential is. Now we can get into the physics of the motor and how I take just the voltage out of the battery, no current, and utilize it to make power. Real power. So, because of this fast switching mechanism of the make and break, there has to be a release of energy from the mass, which is the coil. The coil is the mass. So if you got voltage and you hit that voltage to a mass, you got power. That's where the power is generated. Not from the battery potential, it's what's happening in the coil. The coil is what creates the high voltage spike as well as current. It's all done here in the coil. It's not, all it's asking the battery is asking for voltage. That's it. It's not asking for the current. So the switch controls that scenario. So when it fires off, and it's firing off very, very fast, it's not pulling the current off the battery, but it is able to harness the voltage coming from the battery, which activates the coil. Because of the fast switching that's going on, it's creating a reactive power scenario. So the reactive power now ricochets into the transducers. I got two of them, one's under the wheel and one's here. They're in parallel with the coil. So the transducers, because they're barium titanate, they're a piezoelectric compound. It's almost like a ceramic type compound. And what happens is it creates a bit of a capacitance as well as jacking up the power. That jack up of the power goes back into the coil again and creates that reactive scenario where it's able to jump the voltage even higher. Now, if I were to remove the transducers, I lose about 50% of the potential in my battery, in my coil, which is a huge number. And when it comes to building these motors, that's a huge amount of power loss. With the transducers, I get that power in the coil. All right. Now, I also know for a fact, and I did some digging on this, and it took me a long time to find out, but the diameter of the coil will determine the amount of collapse in the coil. So the bigger the diameter of the coil, the harder and the more violent collapse you have in the coil. It's not determined by turns, it's determined by the diameter of the coil. So this one's only about 2-inch diameter. If I had my choice now that I know what I know, I would go to a 4-inch diameter coil. It would be a big honking coil. But the field collapse is enormous in a large diameter coil. So I wouldn't really worry too much on the length. That's just to add a lot more turns to your coil. That determines how many turns you're going to have in the coil, oversize into your total mass, right? I go by mass. This is 1 pound. All my coils, I don't go by turns. It's bullshit. Don't even bother. You're wasting time with turns. Every time I hear guys out there doing it, they're saying, oh, it's my coil's 500 turns or 1200 turns. It's bullshit. You gotta go by mass. Okay? Even Tesla talks about this in his writings. He doesn't worry about the number of windings. He worries about mass. Energy to mass is power. Okay? Where have we heard that before? Energy to mass is power. Okay? Joseph Newman talks about it extensively when he was alive and had his motor running. And he was running them off little tiny dead 9-volt batteries. He had 84 of them, and he was running a 7,000 pound motor. So it basically tells you when you have a high voltage potential going into a large mass, well, guess what? You got one freaking a lot of power there. Not current. You don't need any current, almost non-existent current in your input. That's why this motor was designed to be a current-free potential. Now that I know what I know and all the experimentation and know what this motor is capable of, I'm looking now for either finding or making a superior battery. The battery that can hold the current. Something that is not going to take away from the current from the battery. If I'm able to create a battery that doesn't release current, well, I've basically got a system now that will never run out of physical power. So if there's some way of retarding or holding back the current from the battery but still allowing the voltage to get through, like a gate, hey, I might have something there. So if you guys know anything about that, please, drop me a comment down there and let me know, because that's what I'm looking for. I'm looking for a battery where I could actually control what comes out of the battery. I can control if it's current coming out of the battery or voltage coming out of the battery. If I can get one where I can control, like retard the amount of current that's being expelled from the battery, that's what I'm looking for. Because then I could start playing with that value and see exactly how much current this motor actually needs from the battery to make it work. And the lower you go, better's your chances of over unity. So if you get a scenario like where I'm getting now, I got 2 batteries, 25 volts, and I've been using the battery pack for a month, and the battery's not dying. It's staying the same. So what it's telling me, number one, this motor is, I'll let you fill in the blank. All right? Because it's not pulling any current off the battery, so therefore the battery doesn't die, which thus means the motor runs indefinitely. As long as those batteries are healthy, this thing will always pump out power. So this thing could actually almost be an inefficient generator, but still be over the top, so to speak, as far as output, because my power source never runs out. So what does that tell you there? I'll let you fill in the blank. So that's where I'm at now. So I'm looking for a superior battery that's going to allow me to control what current comes out of the battery and control battery current and battery voltage. Pull off all the voltage and leave the current behind. So yeah, that's what I want to do, and that's the direction I want to take in the next little while. Is focus on the battery. I've been doing some research on some of the batteries they were making back in the 1800s, and how their batteries actually. There's one guy, actually he's dead now. He died of cancer, or actually some weird. He's another one of those inventors that died because of his invention. And I'm not going to mention the guy's name right now because I can't even remember the guy's name for the life of me. But he's been out there quite a few years. He put out some great devices, and he actually had one of these old batteries from the 1800s that was ringing a little bell, and it's been running for 270 years. 270 years this battery has been putting out current, or well, what he explains is actually static electricity. So if I can make a battery that can last that long and, be able to pump out, a substantial amount of, he said the voltage on it's probably hitting around 2000 volts, but very little current. Well, I don't care about the current. It's the voltage I need. That's how this motor runs. It needs voltage, not current. So I'm going to look around some more. I'm going to maybe even do some battery building. Try to come up with a battery that basically does not die. I think that's where it's at right now with technology. If you can make a battery that doesn't die, you can operate, any kind of generator indefinitely for a long period of time and just keep pumping power out. Not a matter of how much power you pump out, it's the fact that it will run 24/7, 7 days a week, 365 days of the year, and just keep chugging along. So, kind of like a perpetual dynamo, you can call it, I guess. But that's my direction. I know what this motor is capable of. I know exactly how it works and the science behind it. And the next segment, I'm going to show you the inside of the coil, what I've done. I'm not going to totally take it apart, but I'll just kind of give you a brief look inside what I've done as far as building the coils. So, just stay tuned for that. Okay, so here's the second part of the video, and I'm going to show you the core design, which is extremely easy. It's not hard. I used the welding rods. If you can see that in there, I got them all cut up. And these are about 200 thou in diameter, so 0.2 diameter. And then you just cut them the length of the core, and you stack them inside. Now this one here, I didn't want to be stacked to the point where it's a complete core, because if you have too much inductance in the collapsing field, it's not able to collapse fast enough. So when it comes up to the next cycle, it can rebound. This also will determine the amount of lens effect that you'll have on the motor. Ultimately, if you're running a different design than mine doesn't really have lens. So each and every one of these rods has electrical tape wrapped around it, one layer, and that isolates each and every one of the core pieces from each other. So you can see there's quite a bit of spaces in between the core. That's not actually a bad thing at all, because you don't have to have a solid mass inside. All you need is enough mass inside to create a magnetic pull or a push. Okay? And that's what really gives you the horsepower of your motor. John Bandini was actually cutting pipes the diameter of the actual hole that were maybe about 200 thou thick and completely open on the inside. So, and actually an ideal core would be that design, actually using a pipe, a steel pipe or an iron pipe that's not very thick on the inside. It's got a decent size gap hole in the middle, and that would make the best core material in my opinion. Now, if you could get a hold of soft steel, which is very low carbon steel, and have that in a pipe form and put that inside, that would be your best type coil. It would be almost like a core, air core, like a hybrid type thing. So yeah, it's just basically welding rods. These ones are about 0.2 inch diameter, 200 thou diameter, and cut to size. Wrap one layer of electrical tape around each and every one of them. Shove them all inside, and then you can epoxy everything into place. It's very simple. It's not hard stuff. Like honestly, a 10-year-old could make this motor. Really, it's not the fact of the simplicity. It's the science of how this motor actually works. Is real high tech. That's the irony of this whole thing. You know, I'm running a super high tech power system, but yet it's elementary in construction. And that's what I found with the stuff in the beginning, back from, the 18 and 1900s devices that were made. They were so elementary, so easy to build, but yet, you know, they were solid devices that actually worked. Everything back then was analog, none of the electronic stuff that we have today that never lasts. So, yeah, and there's the piezo's there. I got them taped down. They're in parallel with this coil. And yeah, so it's not a hard design. Proximity sensor from a 3D printer hooked up. That triggers the switch here. That runs on a separate channel of power. Eventually I could add it to it, but I like to keep this isolated, the switching mechanism isolated, so I don't have any problems with shorting out or whatever that would destroy my proximity sensor. Hall effect sensor, I guess you could call it. And this is the main power line that feeds into the motor. So it's super simple. It's like I said, a 10-year-old can make this, but it's how it's wired, the components, and how it operates is what's real high tech about it. But not really high tech as far as the construction, because, Tesla was working with stuff even simpler than this. Didn't have any of the electronic stuff that I have here today. He didn't have that stuff. Even the transducers. You imagine if Tesla had transducers like that back in those days? My God, the stuff he could have pulled off with it. My God, that would be unbelievable. But, the transducer stuff like this didn't come along till a lot later. But he was onto it because he was in his 70s and early 80s. He was doing a lot of testing with quartz crystal. And that's the basis of how piezoelectric transducers work. But this one is made with barium titanate, which is probably one of the best piezoelectric elements out there. So, this stuff you can get on Amazon. Pretty much all this stuff you can buy on Amazon or Home Depot. I was able to get that water jet cut, the wheel. Always use ceramic bearings. Okay, this one has a ceramic bearing in it. Always use ceramic. And yeah, so pretty much that's it. I hope one of my Patreons was asking about the core design. It is super simple. It is such elementary stuff here. Such basic. And the thing works better than 90% of those motors that I see on YouTube today. I'm sorry. You guys are just gone totally in a wrong direction, in my opinion, completely. Because you guys are still playing with 12 volts, was a complete freaking waste of time. You got to go to 25 volts, 36, or 50 volts. Get away from the 12 volts, people. You're not getting anywhere. And you're not getting anywhere fast. So, anyways, I think that pretty much sums up what I wanted to show you guys today. Give me a thumbs up. If you can support me, please do. I need it more than ever right now. I'm out of work and money's getting real tight, and my insurance hasn't kicked in, so I'm pretty much on life support right now. And yeah, that would be greatly appreciated. And yeah, we'll see everybody soon in the next video. I got big plans. I'm going to do some more research on these batteries. that I need and see if I can control the voltage and current coming out of a battery. And if I can do that, that would be freaking awesome, because now I can make the battery last even longer. So yeah, that's what I'm looking forward to investigating. And yeah, questions, comments below, thumbs up. We'll see everybody soon.